So the first question I assigned for our homework was about Caren, who spells her name with a C, riding her bicycle. This is from the 2009 exam. So on your list of free response questions, make sure you highlight 2009 and 2011. You've already completed those, and that'll leave us some more to do when we get back to school. Okay, so 2009, Caren rides her bike along a straight road from home to school, starting at home at time t equals 0 and arriving at school at time t equals 12. During the time interval 0 to 12, her velocity in miles per hour is modeled by the piecewise function whose graph is shown above. Part A, find the acceleration of Caren's bicycle at t equals 7.5. All right, so the first thing I would do is I would go to 7.5 on my velocity graph and take a look at how Caren's traveling. We see that Caren is decreasing, right, between 7 and 8. And then, so basically what they're asking for is for you to take the derivative of that little line segment you see right here. Okay, and that will be on the exam, so that's good news. So we have a of 7.5 equals the velocity, the derivative of the velocity at 7.5. And you could just use old school slope to figure that out. Make sure that your units are correct because it was 1 point for the correct answer and 1 point for the units. Part B says use correct units and explain the meaning of 0 to 12, the absolute value of velocity dt in terms of Caren's trip, and then find that value. That will not be tested this year on the AP exam, given them removing Unit 8, but it is something that you can do. If we are looking for what that means, it's a total distance, right? And so this is all the negative area and the positive area all added up together. And so what you would do here is you would find the area of this thing here and just kind of make it positive. And so then it would be this area plus that area. Let me put the pointer on. This area plus that area plus all of this until we got to 12. Okay. So you don't have to do part B. And so now we are officially down 2 points on this function. Shortly after leaving home, Caren realizes she left her calculus homework. How dare she? At home, and she returns to get it. At what time does she turn around and go back? So this is certainly something they can still ask. Because it's just an interpretation of the graph. So if you take a look at this, here she was going in a direction away from home, and then this is where we see she has to go back. And as you can see, it's the same distance as well, so it kind of indicates that she definitely made it all the way home and then continued on her trip. It also shows she was at her home for at least a minute, which makes sense. If you got to run in and find your calculus homework, I'm sure you kept it somewhere safe. So your points here would be 1 for the time and then 1 for your reason. Okay, Larry also rides his bike along a straight road from home to school. Isn't it nice they live on straight roads and it takes them 12 minutes on their bike to get to school? But his velocity is measured by this sine curve where W of t is in miles per minute for 0 to 12. Who lives closer to school, Caren or Larry? Show the work that leads to your answer. So all you really need to do here is integrate and find how the distance that they travel. And so you're going to integrate 0 to 12, both functions, and compare your answers. And so this would not be tested this year. So what I'm looking for on this particular free response question is you've got 2 points for A and 2 points for B. So when you grade these, let me know how many points you got out of 4. Okay, I'm going to make another video of the next problem, and that'll be it.